In this problem, we are sketching the graph of an equation that contains an absolute value. And here we've got a quadratic that is inside of an absolute value. So first, let's just talk about what the quadratic looks like. So here, this quadratic is starting at 0, 0 originally, but the fact that it is -4, so we're thinking of this totally on its own without the absolute value. The 4 is outside of the square, so that means it's going to go down 4 units. We're shifting down 4 units. And then we know parabolas go up 1 over 1, and then they go over 1 up 3, and then they go over 1 up 5. So this is the graph of the original inside before it has a square root on it. But before it has absolute values on it. But what do absolute values do? What do absolute values do? They always take negative y values and turn them positive. So if we look at this graph and we find where are the y values negative, here they are, they're going to turn them positive. They're going to give me the exact opposite. So that means that this point at -4 is going to be at +4. These points at -3 are going to be at +3, which means it's going to do this. So let's put those two ideas together. So this graph is now gone. It's taking the parabola, and it's going to take my positive points, which were -3 and 5, and +3 and 5. And then it took my negative values and turned them positive. So -1 is now at +3. And so is +1. And then 0 was at 4. So, and it also, we were crossing 0 at 2. -2 and 2. So it made the parabola do that. And also that. That is what it looks like. We could get this by making a table of values, but I think if you make a table of values, you're not going to quite know how to connect the dots. So that's why I started with just the original inside function first. So that x² - 4, look at its graph, and then adjust any negatives and turn them positive.